On October 23rd, the U.S. Navy's Air Force Command officially released a RFY contract recruitment proposal, hoping to obtain a new concept for the expansion of the Navy's carrier-based aircraft carrier. The new proposal is mainly used for F-18EF and EA-18 fighter jets, and the Navy has already ruled out the option of air refueling in advance in terms of recruitment requirements. The new proposal needs to start from the aspect of increasing life, reducing resistance, and other aspects related to the performance of fighter jets and improving the F-18's aircraft carrier. So why does the U.S. Navy have this need? Can the F-18's aircraft carrier make another progress? In fact, one of the major reasons why the U.S. Navy wants to upgrade the F-18EF is that the Super Big Yellow Wing will be retired in 2030 and will eventually be replaced by F-35C fighters. That is to say, in the next 10 years, the Super Big Yellow Wing will still be a frequent passenger on the U.S. military aircraft carrier. Although Boeing has announced that it will officially close the production line of the Super Big Yellow Wing in 2025, and in 2025, there will only be 8 new Super Big Yellow Wings on the market. But with the expansion of large-scale refurbishment work, there will still be a large number of early F-18 that will undergo serious refurbishment. Its flight life will increase by 4,000 hours, and the old F-18s that will undergo refurbishment will become Block 3 and will remain consistent with the later new models. And the expected service life of the EA-18EF will be even longer. Boeing will continue to produce this practical electronic fighter until 2030, and the extension of the Super Big Yellow Wing route can basically be used by pilots. Therefore, no matter from which point of view, the extension of these two aircraft routes is very helpful to ensure the ability of the U.S. aircraft carrier strike group to fight in the next 10 years. The reason for this situation is also because the U.S. military's pace is too fast. When the U.S. Navy 10 years ago was still worried about its competitors to launch more powerful aircraft carriers and decide to buy F-35C on a large scale, and to develop the 5th generation of aircraft carriers, the F-18 could only wait for retirement. But the fact is that the U.S. military is really worried. In the field of aircraft carriers, F-35C is not needed at all. The Super Big Yellow Wing is still today's cornerstone. The Russian Navy's MiG-29K is still unforgettable. The Super Big Yellow Wing entered the service of the U.S. Navy in 1999. The U.S. now mainly uses Block 3 models. Compared with the early Block 2, new aircraft have been upgraded in many ways, making it still at the world's leading level today. We actually only need to think about a very simple problem to figure out the cause of this phenomenon. That is, compared with F-35 and F-22 series aircraft, where is the biggest shortcoming of the F-18 and F-16 aircraft of the last generation of the U.S. military? That's right. That's the stealth capability of the aircraft. Because those weapons that have been ordered by the U.S. military can receive long-term configuration updates from military manufacturers, the Super Big Yellow Wing's air-to-air system and weapon system have been strengthened. If there is a performance gap between Russian aircraft and aircraft carriers, then the U.S. aircraft carrier, which has always been known for its strong power, has well guaranteed the mobility of the old aircraft. 20 years later, it still hasn't fallen. Let's take the F-414GE-400 air-to-air engine used by the Super Big Yellow Wing as an example. This engine is equipped with a torsional compressor and a circular combustion chamber. Compared with ordinary compressors, the torsional compressor can accelerate the air into the engine through the rotating blades. It can deal with more high-flow air intake, adapt to the high-speed airflow entering the intake channel when the aircraft is flying, improve the efficiency of the air-to-air engine, and the structure of the engine itself will be more compact. Compared to the live-fire compressor, the torsional compressor also reduces noise and vibration at work. In addition, it is more efficient in combustion than the F-414GE-400 air-to-air engine, which is designed to help the fuel and air to be fully mixed in a circular combustion chamber. The thrust ratio is up to 9:1. The maximum thrust is up to 9.98 tons, and the Super Big Yellow Wing, as a twin-engine aircraft, can get up to 20 tons of maximum thrust. It has sufficient protection in terms of aircraft power. The AD-33 aircraft used in the MiG-29K fighter is also the essence of Russian military aircraft. It uses a lot of innovative designs, but due to the gap between material durability and processing accuracy, it still cannot reach the ideal performance level. Its maximum thrust can only release about 8.2 tons of thrust, and the thrust ratio can only stay at 7.9 to 1. When we compare the MiG-29K with the Super Big Yellow Wind, we will find that the level of the air-to-air engine is already one of the performance indicators closest to the Super Big Yellow Wind level of the MiG-29K. Due to the fate of the Russian Kuznetsov aircraft carrier, it is also a threefold wave. In the past 20 years, it has been either a failure or a modernization. The Russian Navy's next-generation aircraft carrier is also slowly making progress. As a carrier aircraft, the MiG-29K cannot improve in terms of the number of purchases. Now, it is generally believed that the MiG-29K only produced 81 aircraft, of which 37 single-seat and 8 double-seat were sold to India. The Russian Navy has at least 24 MiG-29Ks. All aircraft were delivered at the beginning of 2016. Considering that its test flight work was completed in 1988, the official production work began in 2005, and the main model used by the Russian Navy was a new product in 2016. The MiG-29K is really a long-term project, and more importantly, due to the fact that the MiG-29K has never had a stable order source, the organization's structure of the MiG Design Bureau has often been in turmoil. Until 2006, when the MiG-29K was merged into a joint aircraft company, the technical update of the MiG-29K has not been effectively guaranteed. The gap between the MiG-29K and the MiG-29K has also been constantly widened. The MiG-29K in Russia does not have the same resources as the Su-57, but the MiG-29K's aviation system has been updated several times. First is the cockpit display system. After the MiG-29K arrived at Block 3, it was replaced by a single large-size touchscreen that replaced the previous multiple cockpit displays. Pilots can customize the display information according to the type of mission and personal preferences. Pilots are like getting a military version iPad with a more user-friendly interface. Various tactical images and information can be obtained by pilots in the fastest and most intuitive way in timed operation. The MiG-29K's cockpit interface has never been largely changed on the basis of the original version. It is mainly replaced by different small screens. The display of the original part has been slowed down a lot in terms of information integration. The MiG-29K not only has better information integration, but also improved data processing and communication efficiency. Through the new Distributed Target Processor and Tactical Target Network Technology data chain, the Block 3 mission computer has a better data processing ability. The TTNT data chain can increase the bandwidth of information collection and sharing. The Block 3 needs to exchange a large number of sensor data with the ERD Eagle Eyes precursor, and the better bandwidth can enhance the coordinated combat ability of the supersonic aircraft. Not only that, the Block 3 also integrates the second-generation AOQ-214 comprehensive anti-aircraft electronic resistance system and the fourth-generation electronic warfare kit, and improves the ability of the aircraft to survive in complex electromagnetic environments and combat performance. At the same time, the Block 3 aircraft also installed an infrared search tracking system in the fuselage of the fuselage. This improves the IRST-21 hangar. It will be in addition to the APG-79 anti-aircraft radar. It can detect enemy air targets and enhance the ability of the aircraft to detect and its own stealth when performing combat missions. The U.S. military's demand for the upgrade of the ERD Eagle Eyes precursor is not limited to this. The aircraft not only needs to improve combat effectiveness, but also needs to be more durable. Therefore, in order to extend the flight life, Boeing directly upgraded the fuselage structure of the aircraft. This kind of fuselage structure upgrade is not something that every country can do. It is the rich aircraft development experience that allows military aircraft to have sufficient structural testing and evaluation. When performing full-range probe testing on the aircraft, advanced non-damage detection technology such as ultrasonic probe, X-ray probe, and vortex detection technology are needed to understand the aging situation of key parts such as fuselage beams. It is not enough to just know where the damage is. Strength analysis and testing must also be done. The so-called strength is the interactive force generated by the internal force between the object and the external force. For example, the pillars in the building can build a digital model through simulation aircraft when flying to provide theoretical basis for later modification of fuselage structure. Only after doing this series of work can we know which part is easy to damage and which part is the most resistant. Whether to replace a new alloy material in a certain part or to use another composite material can be used as a reference. In addition to the timely replacement, the protection of the coating on the surface of the aircraft, and the anti-corrosion measures, the flight life of the Block 3 aircraft has been extended from the previous 6,000 hours to the current 10,000 hours. The cost of using and maintenance frequency has also been further reduced. In addition, the stealth performance of the Block 3 aircraft has also been slightly improved. The nose cannon part of the aircraft has been redesigned, and the radar sensor on both sides of the nose has also been adjusted. In addition to the new coating and the new alloy material, the Block 3 aircraft has a certain reduction in the area of radar reflection compared to the initial version. Some of you may ask, why not add the super big yellow wind that used to be fitted with a portable mailbox? Compared to the traditional external mailbox, this is also a countermeasure configuration that can also help the super big yellow wind increase the flight time. But the problem is that the CFT portable mailbox is still not recognized by the U.S. Navy. In the recent recruitment contract, the U.S. Navy still wants a new flight extension plan. In fact, objectively speaking, the portable mailbox is still a good configuration for the super big yellow wind that allows the fighter to carry an additional 1.5 tons of fuel. Although the capacity of the portable mailbox is still not as much as the traditional external 1,250-liter aircraft, but due to its shape and design, it has less resistance, which means that the effective flight distance is still 160 to 190 kilometers, and the portable mailbox does not occupy a single hangar, which allows the fighter to carry more ammunition. But unfortunately, this unique configuration was not selected by the U.S. Navy. In the end, this is still an external equipment, and if it is attached to the fuselage to fly, its structural strength is a potential problem. After all, when the super big yellow wind takes off on the aircraft, the carrier itself needs to bear a huge impact, including the momentary overload when it takes off and stops the fighter. The structural strength of the portable mailbox does not reassure the U.S. Navy, and the portable mailbox is different from the traditional auxiliary mailbox. After it is attached to the fuselage, it may have an effect on the aircraft's maneuverability and maneuverability. So the U.S. Navy would rather not take the 160-kilometer-long aircraft, and the disassembly and installation of the portable mailbox is not as convenient as the U.S. Navy expected. If the operation requires the manpower of the aircraft carrier and the limited space of the aircraft carrier, then the aircraft carrier crew will naturally not welcome the portable mailbox. If there are some additional factors, then the final safety consideration is the real reason to deny the portable mailbox. As an extra part, the portable mailbox may have interference conflicts with the aircraft carrier's ejection system and stop system, affecting the ejection system's pull distribution, increasing the risk of the aircraft's stop gradually. As mentioned above, the portable mailbox is not perfect, and its price is not cheap, and it is not easy to develop. Boeing also admitted when communicating with the Navy that the development of the portable mailbox is indeed more difficult than expected, and the progress is always delayed. So no matter how handsome the supersonic wind is after hitting the portable mailbox, this configuration is also difficult to recover. However, the portable mailbox is not the only extension that the U.S. Navy previously thought of. The reason why the Navy wants to develop the MQ-25 unmanned refueling aircraft is to extend the aircraft carrier's flight path. But the MQ-25's project progress has also been delayed, and it is estimated that the MQ-25 will be launched with the F-35C first. As for how to improve the supersonic wind in the MQ-25, which has been in battle, it has become the current problem of the U.S. Navy. As for which method the U.S. Navy can use to improve the supersonic wind, please leave your comments in the comments section, like and subscribe my channel. See you next time.